Radioactivity. What is it? And should we be worried? It was Mary Curie who first used the word radioactive to describe a phenomenon discovered by Becquerel in 1896. It would be Rutherford who would investigate this further. It was found that many elements had isotopes that were naturally radioactive. They had an unstable nucleus which would decay in an attempt to achieve stability, emitting radiation as they did so. Rutherford identified 3 types of radiation, 2 of which were deflected in an electric or magnetic field. These were identified and named as alpha, beta, and gamma radiation. Here we will look more closely at their properties of penetration of matter. We can detect the presence of radiation by using a GEIGER-MULLER tube connected to a counter. The counter records the number or rate at which radiation passes into the tube. Let us look at alpha radiation first. Addition of paper stops the alpha particles being detected. We can see that alpha particles have a poor penetration in air, and even thin paper can stop it dead. Now for beta radiation. The addition of paper stops some of the beta particles being detected, and the addition of the 1mm aluminium sheet stops all of the beta particles. We can see that beta particles have a good penetration in air and thin paper, but can be stopped by thin metal. And finally, gamma radiation. Aluminium has no effect, thin lead some effect, and even thicker lead more so, but a significant count rate still continues. We can see that gamma rays have excellent penetration as they are neutral high-energy electromagnetic wave. So if we look at the characteristics of each radiation more closely, we can begin to understand why their properties are so different. Alpha is a slow-moving helium nucleus made of 2 protons and 2 neutrons with a double positive charge. Beta is a very fast-moving electron with a single negative charge. And gamma radiation is an electromagnetic-like radio waves, light and X-rays, but is much more energetic. Some people who are exposed to radiation as part of their job, such as radiographers, often wear personal dosimeter badges. These can record the amount and type of radiation that the person has been exposed to by examining the effect on photographic film hidden behind various thicknesses of metal. As you have seen, alpha radiation is easily stopped by air, your skin and clothes, but it can be dangerous if you breathe in or swallow an alpha-emitting material. Beta can pass into you easily, but has low ionizing properties. Gamma rays, which arrive from space naturally, pass right through you, but interact poorly with the atoms in your cells. However, high-intensity sources of gamma rays can be lethal, so although care is needed around radioactive materials, most of us need not worry. Background ionizing radiation is always around us and can cause mutations if it interacts with genetic material. This interaction isn't all bad, as throughout history, evolution has depended on chance mutations that may have arisen this way.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.